the problem. The problem is that after my last change, doing this from 0 to 1, from 1 to 2, and now the next jump we expect to be there, right? But it's going, what the fuck? And I never press space again. I don't know where it is now. 4, okay, now we're here. Oh. And it goes all over the place? No. I don't know, if the debug this. Well, last ever even it was returning something that was all zeros. I think an undefined double. And now I don't see that. What? Maybe I should run it through Valgrind. Try that one more time. Yeah, there it is. Here. Returning all zeros. So that happens after what? So 0.3 should have been at -4, not 0. What went wrong there? So it should go to -4. That's kind of there, I think. Ish. And then actually it's storing 0, I guess. Well, that is this thing. It looks like close to 0. Okay, so I want to debug why it is returning this value instead of this value. And that happens at the moment it prints comma based. So let's find in the source code that text. Now I have to figure out which one that is. Well, this one I think. I'm lazy, I just compile it in. Beep. Alright, well it still has to print it, so let's do next. Comma based, there it is. So now whatever it printed is what I expected to return. That's W. W. No, this is what it printed. Oh, it went from W to gamma based. Okay, this is the value that I wanted to return. Yep. And then what happens? Okay, let's do just step. So we do next, and then state is now set to comma based. Add history. It adds now the old value there. The -3, 3.5. Approximation curve is reset. Oh, wait a minute, it's just a plot. So delete some plots. Not interesting. Plot, 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 plot. If state is, no, state is not changed, I hope. State is still, comma based. Update approximation. Yeah, this should store the W value in the approximation thingy. I'm not sure what exactly happened, so let's do a step into this. So now we are inside update approximation and get pro approximation add. Well, this calls add on approximation, so they cannot change state. I'm just going to do it next. That then did it not print that we entering? Yeah, here, right? This one. So that's a lot of debug output. It did a fit through 10.6. Let's see if I can show that. Yep, this point here, and a new point here at -3.5. Basically, this is W, and sample base W is a little bit over here. Yeah? That was 4.6, was -4 point something. So now it's adding the W value here. That's -3.5. And we fit the parabola through 0.1 and then that point, the last W value. Get this parabola. And the scale is updated. And here you see them again. Scale, blah, blah. Whatever, okay. The result of that is to its vertex. Next, switch that. Draw indicators. Doesn't update anything in our window. All parabola. Approximation. Draw. Still nothing. My window is not updated. Now let me just check if state is still what I want. Yep. And you have that value that we want to return that wasn't touched at all. It's just in this scope. And it was called, I think, gamma base W. Oh, okay. How did that happen? That's weird. Well, this is what we are going to return, and that's the reason. But how did that happen? I was just set in this scope. I'm sure of it. Should even still be able to see that, I think. So the breakpoint happened here. Did I not print that out before? No, I did not print that out before, but it was printed in the debug output. So at this point, gamma base W is defined. Did I double declare or something? Maybe this is another variable. Ah, that is what it could be. Okay. We have a hypothesis. Let's just stop the whole program. And my mouse buffer is empty. It was 539, wasn't it? Yep. So you print out gamma base W with the correct value. Yep, and that's what it happens. It's just a bloody double. The thing is defined here. And I'm trying to set it here, but since the double in front of it, it's a completely different variable. No, bug found. Okay, so I think now it works. What else could it be words? Yeah, now it went to the correct value here. So now it's not returning the weird value anymore, but what was it? 10 to the minus 305. But the correct value, which is here. And before it was, I forgot to add this to the approximation. So then it's plotted a parabola through 3 and 1, or to 2 and 1 even. Yeah, no, 1 and 3. But now we added 2 to the approximation as well. So the next parabola should go through 2 and 3. Oh, it already did that. This is the old parabola, so the red parabola here goes to 2 and 3 now. So now we jump immediately here. Before my last fix, it went 4 went here somewhere. So that was a bit weird. So this is faster. 5, 6, 7 is above the energy level. So now it's doing the right thing. Now it's doing recognizable things. Very good. Hey, Louis. Louis is back. I think I'm going to commit what I have now. Probably even a followable diff. I made a little change to plotting stuff so that I can show that actually. Was that this one? No. Oh, wait a minute. Tests. Gradient descent. Backtrack. No. Parabola fit. Yeah, I didn't stream this. I wrote this whole thing out off stream. So you have here 2 algorithms that fit the parabola through P0 and P1. As you can see, both go exactly through P0 and P1. And then we have a derivative. The derivative is known, as it were. There's this orange thing. And I have a derivative here. And then you see the relative error of the derivative. That is the derivative of the parabola minus the derivative that we expected or want, divided by that derivative. So that means that if and then the algorithm, the formula that I figured out is keeps them equal. Yeah, actually, not this one. This is not a slider. So forget blue. The red one is now the algorithm, and that keeps both length of the red errors are the relative errors, and they are the same, meaning that if the derivative is 0, then the error in the derivative becomes also 0. Yeah, so now the vertex is here because the derivative is 0. I mean, we measure the derivative to be 0 here. So yeah, that is the minimum. So it doesn't really matter anymore what this is. Well, apparently it's not exactly 0. But not really. This is the more horizontal. Really? Wait a minute. No, I guess there or something. No, totally zero. Yeah, no, it doesn't matter anymore. Anyway, the diff that we were looking at is an improvement in dragging the center point. So before, if I drag this point here, the green point would be left behind. So the green point is now here, and then if I drag that, the green point would still be here. So now it's moving along. So it's much nicer, right? So you can just see if I have a derivative like this and like this, then the parabola that you see is the best fit wherever I put it. There's more going on. The move draggable is for, draggable meant that I can click on it with the mouse and then drag it. And the move draggable is that you can drag it then from the program itself, so without a mouse. I just wanted to go there, but then programmatically, as if it was dragged. And that was not the program that I just showed. That was intended for the other one. Which one? Gradient descent? No, I just looked at that. Backtrack, right? Yeah, because here you have a draggable thing that is only draggable vertically. I think I needed it for that. Oh no, I don't need it for that. This is just a restriction, so you can move wherever you want, and then the restriction keeps it on this vertical line. No, this one. If I change C, then it moves horizontally. So this point is draggable, but if I do this, then it is moved. But then by the program instead of by mouse. You can't even drag it horizontal. That was that div. This is my new algorithm now to in the function, doesn't say. What is approximation add maybe? So before I did something, well, this, whatever that is. The theory was here, and now I have new theory, and we do it like that. And this part is then, this new algorithm is plotting a parabola such that if the derivative is 0 of one of those points, then that's where the vertex ends, which makes a lot more sense. In case anyone did not read that yet or see that yet, that would be that link. I'll also post it on Discord, but okay. Oh no! So I'm not allowed to have empty lines here, apparently. No. Two new states. Yeah, here's another one that I also wrote or derived some new theory of, which is well, documented there. The idea of this thing is that if you have let me see if I have a test program to quickly show that. I'm not sure. Let me look at the diff first. I think I can just commit it. I guess I can add this as well. Not sure how relevant it is anymore. Octave script. No, this is all commented out. Maybe I should not add it. Yeah, whatever. Oops, commit. Let's try the other one. No, I think this is about the only case where it is really clear. So here we have a sine as a sinus, sinus, whatever. And 2 points here is super close. So if you fit a parabola through these 2 points, then the parabola has nothing to do anymore with the sinus. But just looking at this tiny little piece here, you expect, if you just think, well, it's probably going to look like a parabola. So we expect the curve to be like this, which is true, but then we expect it to go like down, 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 which is not true. Well, in fact, it goes up. So we expected, if it was a parabola, that the minimum is here, because that's where the vertex is. So W is now going to jump there. And then we say, oops, it's not at the height that we expected with a horizontal slope. So we are not in the minimum. No, we end up all the way up there. And then that other theory is used, and it says, wait a minute, this is such a big difference that it doesn't make any sense to use it even. So it kind of wants to halve this distance, but why not just plot a degree 3 polynomial through these 2 points and that point, and then determine the minimum of that, and then jump there instead of just halving it. It's not plotting it, but that's what it's doing here. So instead of going to trying to find it, I think here, I think minus 0.4, that is this vertex here. But instead we're going to, no, that was actually returned. So this is returned, But then when we get here, then it says, yeah, wait a minute, this is way off. Meaning that the mysterious gamma that was calculated is larger than 1.2. And therefore it's way off. Trust me. Therefore we jump to 6.18 instead. Which is then the minimum of the third degree polynomial fitted through those things. Which is here. And it's much better than there. But still not really in minimum. But okay, now we have this point and that point, and now we can fit a parabola, and that has the vertex almost exactly in the correct minimum already. But not quite, because I know that it is 7.75, I think. So it thinks it's now 7.68, but in fact it should have been 7.75. There's still a little bit wrong. So what happens then? That seems like a poor jump. Oh, mistaken. This is the correct. Sorry, this is the correct value. I was thinking about something else. Not a test, I guess. So we were already almost there. Now it should be exactly there, I suppose. So one more. Oh, I already said it here. Minimum reach already. Okay. So that is 1, 2 to start up. And then 1 here, and then we are found the minimum. And then we do a 4th degree fit, and then we decide to go this way because that one is lower. Jump here. And then again a minuscule step here. And then I guess 18. And now the debug starts up again, which I don't want. I don't know. So sometimes it feels like doing too many probes, like at least one too many, right? Yeah, I don't know. It's better than 100. A few steps. Find the minimum in a few steps. So now something goes wrong again, and I think that's the last thing I need to add to this algorithm, and then it's finished-ish. I mean, this is the last thing that I really know that is wrong. From here we make a 4th degree fit, which is already has nothing to do anymore with the sinus, which is weird because before they were pretty good. I mean, you would expect something like this, right? And now it goes up and up and up and up and up and up. And the vertex of the maximum of this curve is here. So we're going to jump here, which is like way past that maximum and past this minimum. And that's bad because we're looking for a maximum, so it's not going to go back. Jumping past the maximum and therefore going to find that maximum yet next, I mean. Oh, we fit a problem here. Why? No. Well, okay, it fits the problem, but it's going to say, but we were going to the right, so it's going up anyway. Already gives up. Found global minimum here. Yeah. I don't know what that is. Aborting, why? Too much energy used already. No, I suppose it jumps to the energy has dropped to this level, so you can't even reach the maximum anymore here. Yeah, okay. Anyway, the strange thing is that before, I should remove that debugger thing before it starts to pop up again. So before we find this minimum, and then we plot a beautiful 4-degree polynomial, which is a beautiful fit. So at least we know that, there's maximum in that direction. And that works then for this minimum as well. Oh no, it doesn't. Haha, already. Okay, so the question is, why is this fourth degree polynomial fit so bad? And I think the reason is that it is using only points in the very, very bottom here. It's not using this point. And it's maybe not even using that point here. I don't know how many points it used from the very tip here. While the scale of that problem is, let me see, where is you see a scale which is pretty much on the scale of the plot itself. This is the width-ish of the parabola. Yeah. I suppose it's only using the 2 here. But it's still a substantial part of the scale. I mean, it's not like a pixel, like if everything was in this point here. And here, we also have a scale like that. I mean, let's see, in terms of pixels, this is, visible, right? It's not like way big and it's not nothing. Still a good scale. Still a good scale, but maybe my 4th degree is only using points in the very tip, instead of having them spread over that scale. See if I can see that here. See one more space. Fitting a 4th degree using samples at. Now these two are a little bit too close together, but okay, 29 is used as well. So that looks like, okay, there's 2 here in the minimum and then 1 there. That's what is being used. Yeah, I would say that these two are too close together to be used. I don't really like to use both of these. Well, we have another point which is also usable. I could use the point here. And even if I don't have this point, then I think the decision should be made to just do another measurement first, or I want points that are more or less spread out over the scale of the problem that we find. Where does it last talk about scale? See, the scale keeps being -2.32, which is apparently using 26.26, which is well, that point. So this belongs. This is the edge sample, and it should be used. Definitely should be used. And certainly if the last two samples are this close together. Right, so this happens when here. Jude skips it when it is less than a thousandth of the scale. Apparently that's not the case. Could make it 100th, but kind of depends, I guess, if there is another sample available within the scale. So maybe we should search for that first and then make the decision. So it depends on how many points do we have within the scale range. And then just take the ones that are separated far enough. And then 1,000 is not very interesting if there's another. Something like that. No, we are definitely using current, okay. And then I have to find two others. And at the moment I'm doing that a bit clumsy. We have the possibilities that we have are, well, yeah, well, I don't know. I need to think of an algorithm here. Let's just rewrite this completely, as in I'm going to use here index 1 or something, index 2, where then index runs from, no, I first have to find out how many of those things that we have in the first place. See how it works. The count can be at most total number of samples minus 1. So that is a clear limit. So I need to have a loop that runs from 1 till that minus 1. That's all the options that we have. So we do for int I is 1, I is less than total number of samples. Something. It's more than that, I think. It's not just the number of samples, it's the number of relevant samples, actually. Yeah. Let's just call this. So the current one is already stored, so state the relevant samples returns 4. Then current is index 0, and I is then what you pass to previous is the number that we go backwards from current. So if current is at 0 and then we go 1 back, then we pass 1. And if you go 2 back, then so we pass 2 here. Then we go 2 back, and then we have we need in total 3 samples, because that's 2 back, 1 back, and 0 back. So it's 3 in total. So if we have 3 relevant samples in total, then I can be a maximum of 2. So this is correct, using the less than. And then we can examine the sample by calling history previous I, which returns a reference. And then the first step that I could do is if it does not fall within the scale range, to the sample.w minus now we need the x coordinate of the vertex, of the w value of the vertex, but I think that's just the current, right? Because if we even get here, then we are handling a local extreme. So w is already known to be in the vertex, otherwise we would never get here. So I might as well just subtract w. And then if that is larger than the scale, however I got that, and then I just do continue, because we don't want to have anything to do with samples that are further away than the scale. So keep those. So how do I get my scale? Oh, here. That's the scale. Is that an expensive function? Parabola scale, just returns parabola scale, which is just a scale. Okay, how big is scale? Oh, it has a few things. Oh, even a complete parabola and everything. This thing returns a const reference, so that's not an expensive thing. Not at all. I'll just call it again here. Or, no. Just make the reference here. Scale is this. Well, even though it's an object, you can just treat it as a double, because the thing automatically converts to a double, I suppose. I could call value to get it, but it also automatically goes to a double. I'm pretty sure I only need that value, so maybe I should just do this. That's the current scale. Okay, so if this is larger than scale, then we don't want it. Now I get here for all samples that are usable, theoretically, and we want the ones that have the largest value, or at least spread out as much as possible. Seems like I have to sort this. So all the samples that you get, and then sort them in a certain way, and then just use the top three. But how can I sort them such that you get the ones that are the furthest apart from each other? I think I'm going to use here the fact that it is extremely likely that the further we progress towards the vertex, and we just ended up there, the closer the samples become to the vertex itself. Therefore, it's always current plus the last samples that we get. Nevertheless, okay, I'm just storing all the I values, I think, in an array, which is... I could use a vector, but I don't want to use a vector because it's allocating memory, which might be slower. We can just put them on the stack, and I guess that we will never, ever, ever have more than 5 of them. That's like usable samples. But then I must remember how many we have. So usable samples. Yeah, wait. Is it how you write usable? It kind of looks weird. So now every time I find one, which is then here, I want to store it in this array or keep it. So number of usable samples can never be larger than 5. Yeah. I think I can just call standard sort on array now. I mean, this is going to be a super small array, which is probably already sorted. But you just have to make sure. So you need an algorithm to sort array while it is probably already sorted. Probably the fastest way is to insert it at the right spot here. I don't know. Can't use standard sort, I think. I don't think array has a sort. No, it doesn't. So you're using sort. Well, I need a compare function though. So an example here with a compare function. Custom less. Okay. Yeah, here's one with a lambda. I like that much better. Should do something like that. And I don't have an end anymore. Well, not really. We have usable samples begin plus and then the number of samples. So that should be this one thing. And that is then called with int, right? Because that is Oh, this thing is storing double. No, it should be storing ints. It's storing I values. Right, now I want to have them sorted in some order. And well, by distance to the current value, so okay, so this sorts by distance to W2, which is just current value, which is a sample, but also samples are converted to doubles directly, or maybe not. Therefore, we need W2W. And then it's sorted in descending or increasing order, ascending. And I have no idea which it is. I'm just going to try it out, I guess. I mean, one of them, and then we're going to assume, let's say, decreasing order. So the ones that are the furthest away from the vertex are now in the beginning, and those are the ones that we will use then. Or rather the other way around. Although I doubt that it matters. Let's see what the effect is. What am I using here? History. NW2. Oh, wait a minute. W2 is in a thingy, so do it by reference. That should work. An object, I meant. Da-da-da-da, da-doo. Right, let's see. So that's about fitting the 4th degree polynomial, I think. So we get this, and we find the minimum, and there it is. And the question is, what did it do / use now? Fitting 4th degree while using data. Yep, that's the same things, right? Or maybe it's the only thing what he had. Now I think about it. It seems to be using the 2 points here in the vertex super close to each other. And point 2. And the question is, were those the only points that are available, or is one of these points also still within the scale? Maybe it was not within the scale. So yeah. No, let's go to the next one. But this one still worked anyway. No. It does not look good. 17.98 and 17.99 is like the same thing. So, and then 18.4 is I think that one. So either this one is not within the scale and it used those three, but I doubt that. It seems that it's not working, right? It's not working. I think 10 is still within the scale, isn't it? Tells me it is. Maybe it's a bit, the comparison is a bit dangerous, comparing floating points, and then they're just on the edge. So I probably should compare it a little bit differently, so it definitely takes that one into account. But well, it works. That is, we're getting a very sane 4th degree polynomial now. Before it was blowing up all the way and we ended up here. And now we get just those. So which is it using here then? 4th degree using well 28. Yeah, I'm not sure. I think it works. I think it's using this one, and then the other one is skipped, and then using this one and that one. This one is like 26 something, right? No, it's not. Okay, I was not looking correctly. These are still super close together. Damn it. Okay, we'll just use the other one. Actually, I'm gonna change first this whole scale thing. Scale times 1%, otherwise get the problems of running off errors. Well, let's even allow 10%, because if you can get something almost within the scale, then I'm totally happy as well. Yeah. There's something changed because now you get a good fit here, but it's not using 26 something, right? Nope. So that was not it. Then we change the sorting. That's sorted in the other way. Other order. Looks even better. Let's see. Yeah, now it's using 26. Oh, and it's using 2 points in 20. What the? Yeah, we do have 2 points here, right? They are super close together. I think maybe it's 9 or something. 8 is here, so 8 and 9 are super close together. They're actually closer together than this point here. So now we have 2 points that are very far from the vertex and the vertex itself. But it would probably have been better to use that point there than 2 of these. Because this distance is larger than that distance. So the sorting by distance from the vertex might not be the best. No, I don't think it is. I want to find the 3 points that are relatively the furthest apart from each other. How the hell do we do that? You have at most 5 points, which is already ridiculous. We'll probably never have that. Maybe we can just brute force it. Or it's starting to become ridiculous now. Let's see, so we have 1, 2, 3, 4, 5 points. And the vertex point. So that is 5 times 4, 20 possibilities. Yeah, we can just brute force that, right? Especially because we probably never have 5 points. So that then drastically gets less and less. Okay, yeah, I'm gonna do that. Just brute force it. Horrible coding. You could call this horrible coding, but well. Does it not matter which one I use? If W0 or W1 is closer to the vertex? I don't think that makes any difference, right? Yeah, I don't know. I don't think so. No, probably not. Probably not. Yeah, sorry, I just don't ever put two variables on one line, so do it like that. And if it makes sense to do this, do it, and otherwise do it not. And it makes sense when we have at least 3 samples. And then we're going to run over I0, runs over all of them. Yeah, and the other one as well, but they are interchangeable and I don't want them to be equal, so I might as well do I1 equals I0 plus 1. I1 is less than number of usable samples. Plus that. Which then means that it does not make any sense to go further than -1 here. Rather, damn it, rather. No, here we find out if this is better than the previous thing, and then I set I0 equal to what we found. Let's say the test. So this is the better one then. So then this must run over T0. So it's better than we remember it. Now, what is better? The spread. I'm gonna have some double called spread. And I guess the minimum here is 0. That's absolutely horrible. So then if current spread, this spread, test spread is something. And then if the test spread is better than the last spread, now I'm going to call this spread. Let's call this best spread. Then I remember it, and of course we set best spread to spread. And then I need a formula for whatever spread is. How about the sum of the squares of the differences? Well, for that to work, I need to know the W values. So W2 is current. What am I doing here? W21. Can move that one up. Well, we can even do all of this already, but that is maybe a bit nonsensical. Let's do that one here. So then this is W21. And I need the W values of the two samples that we're testing here. Let's call them W0. So I'm going to add 3 squares. Oké, komt ie maar. Compile. Oh, that's an int. Yeah, I need a history. History dot previous. Now what did it use? That looks better. No, it does not. Damn it. Maybe we should print how many we have in the first place, because this is no fun. I don't know if it works or not. Yeah, okay, so there is only 2. So that's the only thing we can do is just use them. Well, 3, including the local minimum. And then continuing this one. Now we have 4 of them, so that would be interesting. Yeah, now they are nicely spread, I think. This is significant distance, 1.4 difference, and these as well. I suppose it used that one, and that one, which is still visibly to the right. And here now we also had 4 samples, and yeah, 26 is being used. And these are reasonable far apart. I think now it totally works. These are the best samples that you can pick. And the result is indeed good, much better than before. We ended up here instead of here. And then we find that one, and 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 then we stop. And now we found the real global minimum. -1. There it is. First time this one worked. However, that's of course still possible. We don't have enough samples because 2 samples are like way too close together within that 1,000th of a scale width. In which case maybe you just should not try to fit a 4th degree polynomial to begin with and just get another sample. Louis, you know why, right? It's a C thing. So you have in Colonel Ritchie invented C, and they thought it would be a good idea to do this. And then you have 2 ints. And then someone came along and he said, hey, we need pointers, so now you have a pointer to I, and I wrote it like that. That's a C thing. Whoa. No. I'm doing the C++ thing already. Automatically, like this. They wrote it like this in C. So now this is a pointer, an int pointer, and this is an int pointer. But then C++ came along and they added a gazillion type qualifiers and stuff, and in the end people realized that the star is really part of the type. So if you want to have type variable, then you have int pointer variable. And now we had a problem with backwards compatibility because if now you write this and you want that to be compatible with the old C, then I is a pointer to an int and j is an int. Oops. It's like writing this, which used to be j is an int. And the only solution is not to do this, but to say, okay, fuck it. Never ever put 2 variables on one line. So problem solved. And that's why I said I don't like that. I just refuse to put a comma and then another variable. It's just not done in C++. Let's see. Okay, so I have kind of a problem here that if... Well, I don't think I added the 1,000th out, did I? Okay, well, no you do. Yeah, C++ has certain flaws. It's not a perfect language, but you have workarounds like, well, that one. I'm defining skip sample but not using it. So the problem here is that if skip sample is set, then the previous sample is just way too close to the current one, which is pretty likely to happen. And if then we have only two usable samples, then basically we don't have enough samples. In which case I would rather get another one maybe first, or yeah, I think that's the most efficient thing to do instead of just jumping somewhere and then recovering. What the F is the W here actually? It should be in the... It should be current, but I can't even remember that we have a W here. Oh, that's the weight. Have what? No. What? And when I tested it, it actually made sense. Oopsies. What? No. You gotta be kidding me. Yeah, that should have been 2-1. Oopsies. Oopsies. Okay, and then here we do more or less the same thing. So let's do that separately. Distance is like already absolute, right? Just call it distance. Yep, so if ever we don't have enough samples, then I need to fix this. Which line, LD, which line are you talking about? Oh, you just said it. This one, yeah, well, normally I use a prefix, but in this case, postfix is what is necessary. That's why I use postfix. And it must be a postfix because the first sample, the first index that I want to use for this array is 0. So I initialize this to 0. It's a number of usable samples. We don't have anything yet. And then we store that in index 0, which is the first index of the array. And at the same time increment it. So this stores it at index 0 and increments the number to equal the number of things that are stored. Oh, I don't think it's really confusing. It's super close to doing this. So you have some pointer and then you some pointer and you store some value in it. You store the value to where the pointer is pointing and then advance the pointer. Basically what you do here as well. So it's a postfix. It's logical, actually, I think, but. It's a kind of, maybe I've coded also a long time in C. Maybe that's why I'm used to it. In C++, they went all, containers and iterators and stuff. But on the other end, the standard array is a thing. And that uses indexes. So I was just to give an example of the pointer, but replace pointer with iterator. That would be more modern. So yeah, we could have an iterator pointing at the first element of the array and then do exactly the same thing. Right. Trying to think what am I missing still here? Apart from that assert that I just added, in case there is not enough samples left, which is definitely possible. Maybe I should just code it before the assert fires. I use CXX as extension because CXX is the Unix abbreviation for C++. Call me stubborn. I'm a bit of a guy that does what is most logical and not what everyone else is doing. So if the whole world uses CPP, and I think deeply about it and I come to the conclusion that CXX is the right way, then I use CXX. And it is the more logical way anyway. I mean, it's, you know, the CXX flags, that's the variable. CPP stands for C preprocessor. You have CPP flags, I bet. It's some flags that are passed to the preprocessor. So why would I call my C++ files .cpp? Just a stupid Microsoft thing. They introduced it. But by all means, yes, by far, if not by far, most C++ programmers use .cpp. I won't get mad at anyone for using that. CPP flags is preprocessor flags. CXX, that's the environment variable for the compiler, for the C++ compiler. It's not CPP. No idea why they started to use CPP. Probably because Microsoft wanted to do everything different. Everything was already done by Unix. They do it differently. I think it should just go to bed. It's like 1.5 hours past time that I'm trying to go to bed, which then usually becomes beyond two-step. No, I'm not sure. I don't know what he used. I mean, there's many things, right? The capital C, CC, and of course CPP and CXX. Do we have any other things for C++? It's about sums it up, I suppose. Maybe the whole C++ thing itself is it should have been ++C. But I guess it's not as nice to use for certain file names and stuff. Oh, headers, yeah. Well, yeah. I'm using .h, but that's kind of not really defendable. Headers are definitely language dependent. So I probably should use HXX. Most people, I think, use .h. Boost uses definitely HPP. And you can read the PS plus, you know, if you want to go the I think that's why Microsoft uses CPP. It's just C++. Well, the XX is basically, yeah, we wanted to use pluses, but the operating system doesn't accept a plus in a file name. So let's type X's, which can at least look a little bit like a plus, but then rotate it. That's a really dirty reason to use an X, I have to agree. So maybe they were right to make it the P of plus. If you just read it as C++, then it makes sense. But hey, then Boost comes along and you calls the headers HPP. What's that? Header plus plus? Highly dubious. I want to think of what I still have to do, really. Is that, am I done now? No, wait, no, I'm not done. Haha. I still need to implement the backtracking itself. Although now I fixed so much that the whole backtracking is not necessary anymore. So maybe I should come up with a test where it is still necessary. Some really noisy thing maybe. Yeah, it's not finished. No, it's not finished. Definitely not finished. Okay, I can even point it out, I think, in the source code. I have expected somewhere. I'm defining this variable here, expected LW underscore. And every time I set W with according to some algorithm, this algorithm here is, we went past the extreme because there were no zeros, blah, blah, blah. Here the algorithm is keep going because there are no zeros, and here is, well, I have more of those. Algorithm string, so we have avoiding replacement, one sample same direction, one sample gradient descent, one sample derivative is 0, and so on. And then every time I set the W value, I also set the, according to that algorithm, expected value of, well, the loss function or whatever the function that you're trying to minimize. And then if that deviates too much, then alarm bells should go off. So we have a certain expectation, and then we try it out, and then if the unknown function that we try to minimize doesn't look even close to what we were expecting, then the idea is to backtrack to half the step size until it does look again like what we were expecting, more or less. However, even though I'm setting expected everywhere, well, not everywhere, by the way, it's explicitly not set, because I thought I was CPU intensive and I don't know the formula. Plus, I knew it was ignored anyway, so I didn't set it. But everywhere else it is set. And then the question is, where is it used? Assignment, printing it, 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 assignment, comment that out, assignment, printing it, assignment, printing it. Oh, is it used here? I guess it's used here. Yep, it is used here. So it's currently only being tested if the state is vertex jump. So if we jump to the vertex of a parabola, then the expected value is compared with what we really got, the LW. Not in any other case. And I think I should just therefore still implement, yeah, the check if we deviate too much from the expected value for all the other cases. Yep, definitely bedtime. So you know what are you going to do then? It's bedtime, I should go to bed, it's sleep. Therefore we go play chess. Could also do that in bed. But I like to lose a game here. So yeah, I had 2000 plus, and then 2000, almost 2050 again. And then bang, everything. I lost everything. I played so stupid, it's unbelievable. I went really deep down, all the way to the bottom of 1900. Pawn here. It checks that, so I probably have to go. I could push it. No, because he plays the knight anyway, and if I go away, then the knight comes here and I have a problem. What the hell? I feel like doing that, but I can't. Take. This move I have to anticipate, and then I could, after he takes, I can push this one, but nothing really helps. If I go there, then he could take there, and I can take with the queen, and then he takes there. That would be horrible. I don't think I can take there. I can't push this. No, I cannot. Yeah. I could pre-move the queen takes, but suppose he takes the queen. Then the pre-move would be bad. Very, very unlikely, but in that case I would want to take with a pawn. Now the queen here came only there because he wanted to make a double pawn here. So come on. Or are you just gonna stand there blocking your knight? The knight goes here, and in order to go there, in order to go there, I probably have to push this pawn. In all other cases, I can just put my bishop here, and then develop my knight before I push the pawn. Okay, so in this case it just puts it immediately. No, I think I've won this game. Isn't it like very bad for this? Oh, he's gonna give check. Yeah, well, I did go there and then check again, and I don't know. Takes the pawn. Wait a minute. I'm not gonna take that. Now I'm confused. I'm a pawn up. I'm still a pawn up. When I completely immobilize these knights, I'm threatening to push this one. Oh, it takes there. Maybe first this one. Well, that doesn't do anything at all. Okay, I'm push this one. Now I can push this one. Because where is the knight going? Oh, the rook is gone already. Yeah, okay. Maybe then pushing doesn't help me much. Pushing this would be nice. Let's develop my knight. Really not very creative. That was so expected. Oh, that was stupid. I only went here because I didn't want the rook to come in. But the knight is also defending it already. Now, what is my bishop doing there? But okay, let's exchange the rook. Yeah, I should have kept my bishop here. Damn it, I just lost my plus pawn. I am such an idiot. That's a free knight. He's gonna give up. Ah! Oh no. Thought I mismade him one, but my bishop was here. Yeah, he resigned anyway. I'm gonna try to reach a rating of 2000 again. No, I should go to bed. Yeah, let's go to bed. This really should be the last game. And then I go to bed. Shoot. I have to get up early tomorrow. Well, early between quotes. This one. This one. That one. What kind of move is that? Does not make any sense whatsoever. Oops. Let's stop this pawn. This pawn is a good move, I think. It doesn't want to move. It does not want to do good moves. And I probably should have moved this, but well. Yeah. Let's just play that one. Queen should go here, I guess. Now the pawn comes. But then what about this move? Oh boy. I should probably just castle. Let's castle before I regret it. Though I don't like this move. Totally not like it. Can also push this pawn if he doesn't come forward. Maybe. Yeah. Oh, what is that? What kind of moves are that? Okay, so he pushes the pawn. I take, he takes, and I still have to go. I don't like that. Then I can go here. Take, take. It's all a bit vague, isn't it? But if it comes forward, I just go here. Take, take, no problem. Okay. Plus with the queen here, I guess he wants to move that one forward. Okay, I'll just take him. Shall I give a piece for the whole center here? Almost the whole center. Take a pawn, take, take, and then the queen goes, and then could probably go there. Rook moves. No, no, the knight is there. Yeah. 2 pawns for a piece. Probably not worth it. Not yet, anyway. Looks very attractive though. I'm gonna do it. If I lose, I'll lose. It just feels like the right thing to do. And probably just bad. Definitely bad. But it's 2 beautiful pawns. It costs a piece, but hey. Okay, now he's annoying. Very annoying. No, I can just go back. Not what I wanted with my knight, but hey, it's again a tempo. Semi. Where do I win my next pawn though? Because I have just gotten nothing from it. Let's pester white until they get scared. Oh, he's not getting scared. Going to double my rooks. Attacking this pawn, the 3rd pawn. Yeah. Defend it. Thou shalt defend it, because you don't want to lose your 3rd pawn. That would feel really bad. That is the only advantage that you have. He doesn't fall for it. Where does my queen go? Can just go a step back, I guess. Still attacking it. Yeah, grab the pawn, right? Grab the pawn. Could take the knight, but I'm afraid he's gonna take my rook then, and then I'll get a free pawn. Takes back, I can defend it. Maybe. Okay, let's take here first. It was kind of looks good if he takes a knight first. But he doesn't. Now then we do this. Now he has to take the knight, and then he gets at least this moving. So I have a nice free pawn now, instead of I didn't win that pawn back yet, but you know, let's start pestering this pawn. Hmm. I'm running out of time. Put the knight back maybe. I can push this one. Then the bishop goes there. Oh, it doesn't. Well, in that case, let's attack the knight again. Oh. Oh. Oh, and a bloody rook away. Life is so unfair. This is so not good. Damn it, damn it, damn it. The stupidity of it all. Yeah, okay. Too late. Didn't want to attack my pawn for some reason. Oh, so nasty. Nasty, 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 nasty. Yeah, I can't do that. Very good, very well played. Unfortunately for him, he just gave a pawn away. Gave a pawn away. Oh man, oh man, oh man. Man, that I still win this. Unbelievable. It is unbelievable. That is a one game. Poo poo. Guy wants a rematch. Okay. No, I was going to bed. Shit. Okay, well, this moved very fast. Can still abort it. If it reaches 10 seconds, we abort it. Go to bed. Yeah. strategically on. Well, strategically on. The plan is to play this pawn up so he can't break with these. And then walk to the center with my king and then win with my plus pawn here. The only thing I should not do tactics. Oh, that was still possible. I missed it. Not good tactics. I should start walking with my king, because that was the plan here. Bit of a pickle here, man. This pawn is weak and I can't move my bishop. My king is in the way, in other words. It's still in the way now. Shit. So he plays a rook here. I have a problem. Unfortunately, he's not doing that. Oh no, I'm standing in front of my rook. I'm messing this up. Really seriously messing this up, man. Come on. The stupidity of it all. Just gonna go here, I think. So, yeah. As if I intended it. No, get pawns together. So the plan is the trick. Well, I don't know. I'm way too bad to execute it, but the idea of this opening is that you can't break with these pawns. If he just comes forward, I do nothing. If he takes, I take back. While here I have a free pawn. But in order to make that a problem, I have to move my king up. I'm seeing a weakness there, like a really big, sore weakness. Yep. The weakness is still there. My king is in front of this rook. I desperately need that one. Push, take, pawn takes, and then I have my free pawn, but he attacks it twice. I can just defend it, it seems. No, the knight is covering the square. I'm just too late. This is pure horror, man. What about this move? The knight is now in front of the rook. So I go here, I'm trying to attack that. Does he matter? No. Does he mind? No, he just takes the pawn. Man, this is so bad. What if I move here? Now at least I can go there with the king, but if he pushes that, I want to be able to push, so that's also not possible. I have to exchange stuff. I have to go away from my king. Can I just put my bishop here now? Shall I just give up the pawn and do something on this file of the rook? So I go here, and what is he going to do? Nothing, right? I mean, nothing really. It's just far away still. Maybe I have time to just move my king here. But I'm going backwards. Oh, the pawn is dropping. Yep. My pawn is pinned, so he could give this check. And if I go away, then he just takes here. I lost all my advantage. All of it. And I'm still having the same problems as before. I think. Oh no. Now I give this pawn away as well. Wait, I can take back like that. I can just defend it. Then I push this pawn. Jesus. Take, take. Take, take. Take, take, take. I'll lose another pawn. I'm totally dead. Yeah, I can just take here now. That wasn't good. Oh my god. I think he missed it. He missed his... He missed it. He gave a pawn instead of winning a pawn. What the fuck, dude? Oh, you can take here. Rook takes, king takes, bishop takes like that. On a king take, I take back with the knight. That still works out. He gives this. Oh, he gives. Okay. Yep. And if we go here, then what? Then he can take here. But then I take there first. Is that not a problem? Fuck this. Yeah, I just takes it. Obviously. Shit. No, it seems we still win. It's a miracle. By some miracle. Go back. I want a mate in. A mate with two knights basically, yeah. And a pawn. No more rematches. No. I would just so go to bed now.